All right, let's talk about the invisible engines that power so much of our digital world. Today, we're going to demystify two incredibly powerful tools, Apache Hive and Apache Spark, that make sense of the absolutely massive amounts of data that are shaping everything around us. Okay, to really get this, let's start with a thought experiment. I want you to picture a library, but this library is the size of a planet, and it's filled with trillions of unsorted, chaotic digital files. We're talking petabytes of data. That's millions of gigabytes, just dumped into a massive file system. Now, how on earth do you find one specific piece of information in all that chaos?
And that, right there, is the core problem of big data. How do you ask a simple question of what feels like an infinite ocean of files and get a coherent answer back without waiting for a million years?
Well, the first brilliant solution to this puzzle was something called Apache Hive. You can think of it like a master librarian, or maybe a universal translator for data. The genius of it is it doesn't try to move or reorganize all those files. Instead, it just lays a logical map, a schema, right on top of everything, making sense of the chaos.
Now, here's what was so incredibly clever about Hive. It let people talk to this mountain of data using a language that millions of data analysts already knew like the back of their hand. SQL, structured query language. There was no need to learn some bizarre, new, complex way of doing things.
And this was a total game changer. See, before Hive, if you wanted to ask a question, you had to write really complex, low-level code using this framework called MapReduce. MapReduce is super powerful. It breaks a huge task into tiny pieces and runs them all at once. But man, it is not friendly. Hive just swept all that complexity away. Suddenly, analysts could just ask questions using the language they already knew.
I mean, just look at some of these commands. You don't have to be a coder to recognize words like create table, select, where. This is the basic language of databases. This is HiveQL. And the fact that it looks so much like regular SQL is what threw the doors wide open for a whole new wave of people to start working with big data.
Okay, so you might be wondering, if Hive isn't actually moving the data around, how does it make searching through all of it any faster? Well, it all comes down to some really clever organization.
So how does it do this? The whole strategy is simple. Don't search everywhere. Only look where the answer could possibly be. And it pulls this off with a really smart three-level system: tables, partitions, and buckets. You know, it's exactly like organizing a gigantic library. A table is like the whole library. Partitions are like organizing by genre. Fiction over here, nonfiction over there. And then buckets are like organizing each genre by the author's last name. So when you're looking for a specific book, you can just ignore huge, massive sections of the library. It makes the search so much faster. Now, let's peek under the hood for a second and see the architecture that actually makes all of this work. It might look a little complicated at first glance, but it really boils down to just a few key pieces. The absolute heart of the whole thing is the metastore. It's the brain. It's the library's central card catalog. It knows exactly where all the tables, partitions, and buckets physically live. So when you run a query, the driver, our librarian, checks the metastore to figure out the fastest possible plan, and then it hands that plan off to the execution engine, which is the heavy lifter that actually goes and grabs the data. So Hive brought order. It brought accessibility. It made big data manageable. But as the amount of data just kept exploding and businesses needed answers faster and faster, the next big challenge was just pure velocity. And this need for speed, for more interactive, real-time analysis, led to the next massive leap forward: Apache Spark. Look, if Hive is the slow, steady, and reliable tortoise built for these huge overnight jobs, Spark is the rocket ship built for one thing: unbelievable speed. And it gets that speed from one fundamental difference in its whole philosophy. So what's Spark's big secret? It's all about something called in-memory processing. Think of it this way. Hive is like a chef who has to run to a giant pantry, the hard disk, for every single ingredient they need. It's slow, it takes time. Spark, on the other hand, is like a chef who has all their ingredients prepped and laid out right on their countertop, right in the computer's memory. By avoiding that slow trip to the pantry, it's just dramatically faster.
So let's go a little deeper. How does Spark actually pull off this incredible speed?
What you're looking at here is the core idea that makes Spark so powerful. It's basically a manager-worker model. You have one manager, called the driver, which figures out what needs to be done. And then you have a whole bunch of workers, called executors, that do all the actual number crunching at the same time across lots of different machines.
By splitting up the work like this, and this is the crucial part,
By keeping the data in the computer's super-fast memory, Spark can process data up to 100 times faster than those older systems that Hive used to rely on. It's a staggering difference.
And at the very core of Spark is its real secret sauce, something called an RDD, or a Resilient Distributed Data Set. So let's break that down. Distributed is easy. It just means the data is split up across lots of machines to be worked on in parallel. But resilient, that's the really clever part. It means Spark doesn't just know the data, it remembers the steps it took to create that data. So if one of the worker machines suddenly dies, no big deal. Spark can just automatically recreate the data that was lost and keep right on going. It's this built-in safety net that makes Spark so powerful and reliable.
Okay, so why should you care about any of this? Well, the next time you get a perfect movie recommendation or see a social media feed that seems to know exactly what you want, just remember what's happening behind the scenes. It's the organizational power of something like Hive and the lightning speed of an engine like Spark working together. They're the invisible gears of our modern digital lives.
You know, the story of Hive and Spark is really a story of evolution. First, we had to create order out of chaos. Then we had to achieve incredible speed. It really makes you wonder, with data getting even bigger and our need for insights getting even faster, what's the next chapter going to be? What comes after Spark?